All right, calculus. Welcome to your first video of 2023. Here we go. We are in the related rates notes packet because hopefully by this time we've done the first three. This video is for Monday, January 9th. All right. So what we're gonna do is I picked out I picked out five that are pretty easy. All right, these shouldn't be too bad at all. Again, we're going to take our time with this 30 question packet. We're going to take our time again. Obviously, after we're doing these notes, you are continuing to prep for that test that is going to hopefully be next week. Again, we'll find out how long that jury duty is, but I will communicate with you. We're practicing for that as we are looking at these notes, after we're looking at these notes here today. So here's what example 4 says. Each slide of a square is increasing at the rate of 6 centimeters per second. What is the rate? At what rate is the area of the square increasing when the area is 6 centimeters squared? So what does it want? Again, you always need to know what is it asking for? At what rate is the area increasing? All right, at what rate is the area increasing? You want dA dt. All right, the derivative of the area with respect to time. That's what we want. We want dA dt. And what do we know? First off, this is a square, so all the sides are the same. So I call this like x and x. So I got to have a formula that I can take the derivative of. I know that a is equal to x squared. Again, a of t is equal to x of t, all of it squared. Again, what is related to rates? It's just implicit differentiation. So I need to take the derivative of this formula. When the area is 16, when the area is 16, so when the area is 16, that means that x equals 4, 4 and 4, all right? So here's my formula. I need to take the derivative of my formula there. All right, again, this is what it's showing you. So look, again, I want you to think. And they also, I'm sorry. What did they give you? So we that is important. Okay. So again, don't. This is fine. As we're starting earlier, I think I wrote this on. What this means, but this is when we talked about implicit differentiation. The other day. Or in the last month that we wrote something down like this. But okay, so we want dA dt when x is 4. But what else did they give us? They told us that x is 4, and also each side, not slide, of a square is increasing at a rate of 6. It's increasing at a rate of 6. So they've told us that dx dt is in fact 6. All right, so dx dt is 6. So again, here's what I can think. I can think of it as like this. I can think of it as a of t, because the area is affected by time. It's increasing with respect to time. Could be decreasing as well. It doesn't matter. So it's all about what is changing with respect to time. What is changing? All right, so then we got... I have, someone's bugged me, and this is the third video I'm making today. I've had a visitor in the previous two. Almost had a visitor here, but they were to mouth making video. All right, so this is what's going on. A of t is equal to x of t squared. Okay, so let's take the derivative. So that's a prime of t is equal to 2x of t. Now I have to take the 1 power less. Now I have to take the derivative of x of t. All right, again, instead of writing a prime of t, what's the derivative of the area? It's dA dt is equal to 2x dx dt. So x prime of t is dx dt. Okay, so again, we want to go from here to here after a few days. We want to go from here to here. All right, so dA dt is what I'm looking for. I need to figure out what dA dt is. is equal to 2. I know what x is. At the moment I'm looking at this, x is 4. And dx dt is 6. So that's 48. 48 what? Centimeters squared per second. Centimeters squared per second. All right, we're going to look next at 9 followed by 10. Number 9, a cylindrical tank with radius of 5 is being filled with water at a rate of blank. Derivative. How fast is the height of the water increasing? Now, you're like, oh man, I got 3 different variables here. We actually don't with the cylinder, okay? So, actually, this is the first time we've talked about the cylinder. Folks, on a cylinder where something weird is not happening, the radius is actually constant. So the radius for a cylinder, it's constant, right? Because you have bases that are the same. The cone, it's not constant, but the radius is constant. So the radius is actually never changing. As soon as you got like just the tiniest height down here, the radius is going to stay the same. It's the height that changes. So the radius is not changing with respect to height. It's going to be constantly 5, okay? So what did they give us? It's being filled with water. So filled means it's a positive derivative at a rate of, folks, that is volume because it's cubed. So they told us that dV dt is 3. dV dt is 3. So what's the volume of a cylinder? Volume is the area of the base times the height. What's the base? Pi r squared. Pi r squared times the height. All right, so again, I can think of this as the following. So what is changing with respect to time? So velocity is changing with respect, not velocity, volume is changing with respect to time. Pi's pi. The radius is constant, and height is actually changing. Okay, so that's h of t. So if I took the derivative, it'd be v prime of t is equal to pi r squared h prime of t. All right, another way to write that is dv dt is equal to pi r squared dh dt, which I wrote here. Now, I just substituted like the volume, I'm sorry, dv, this is dv dt right here. So you should write down dv dt is equal to pi r squared dh dt. Just so happens that dv dt is 3, so the next line is 3 is equal to pi 5 squared dh dt. 3 is equal to 25 pi. I'm going to divide both sides by 25 pi. That is an okay answer. 3 over 25 pi meters per minute. 3 divided by 25 pi. Make sure you use parentheses here. 3 backslash 25 pi. It's roughly that. 0.0382 meters a minute. All right, man, the cylinder isn't easy. It's a very classic question. It's a very easy question. So is the sphere. The radius of a sphere is increasing at a rate of blank. They've given you dr dt. It's increasing, so it's positive. Dr dt is a positive 4. How fast is the volume increasing when the diameter is 80? So what do we want? We want... How fast is the volume increasing? We want dV dt when the diameter is 80 or the radius is 40. All right, so we got to take the derivative. If we want dV dt, we need the volume formula. Volume of a cylinder, as we all know, is 4/3 pi r cubed. All right. So, again, you can think of it as V of t is equal to 4/3 pi r of t cubed. V prime of t is equal to 4/3 pi 3 r of t squared times r prime of t. All right, sorry, that doesn't look good at all. Or, going from here to here. dV dt is equal to 4/3 pi 3 r squared dr dt. That's what you would get here, 3. And the 4/3 cancel. The 3 over 3 cancel to give you 4 pi r squared dr dt. The radius is 40. Dr dt, they told us, is 4. 40 squared times 16 is that. pi. You can put it, this is a fine answer. Or that also works. Okay? Again, we take a long time to go through this. That's why it's great that you can take this class in high school. We're just going to do 2 more here. The bottom of a rectangular swimming pool is 25 by 40. Water is being pumped into the tank at a rate of 50 cubic meters per minute. Find the rate at which the water is rising. So that's height. Okay, so again, you're gonna have a constant. So what's changing is obviously the height. The height's going up. The area of the base is going to be constant here. Okay, so volume is length times width times height. Now, length times width is the area of the base. So volume is area of the base times height. And the area of the base is constantly 1,000. Okay, constantly 1,000. So really my formula is just volume is 1,000 times the height. So dV dt is 1,000 dH dt. What's changing with respect to time? The volume of the pool, and then the height is changing. It's going up. It's going up. So dV dt is 1,000 dH dt. I know dV dt is 500. That's what they told me. I need to figure out what dH dt is. 500 divided by 1,000 is 1/3 cubic centimeters per minute. Okay, which is not it's not a ton. The height. Wait. What did I? That's incorrect. Yeah, height is just. Oh man, I emailed these answers to someone. Another SLU teacher wanted to see these, and so that's not good. So that's 1/2 centimeters a minute. So it's not increasing very quickly. You know, it's a good size pool. All right. You know, if a pool is going to be 5 feet high, you can figure out how long it's going to take. And not the balloon one. Last one we're going to do here is number 20. Then that's going to be a good day. The side of a square is increasing at the rate of 0.2. You honestly don't need calculus for this. Find the rate of increase of the perimeter of the square, right? So the perimeter is 4s. I put an s for side. The perimeter is 4s, and they gave me ds dt is 0.2. You can kind of intuitively know it's going to be 0.8, right? 4 times 0.2. So what's the derivative of perimeter equals 4s? Perimeter is changing with respect to time, so is the side length. dp dt is equal to 4 ds dt. dp dt is equal to 4 times 0.2. 0.8 centimeters a second. All right, use the rest of the time today, folks, to keep prepping for that exam. All right. See maybe what you can do in the related rates homework sets that you should have by now. This is Yak Math Videos, signing out.